Let's write the equation for the reaction between potassium iodide and lead nitrate, and then we'll balance the equation. This is in solution. So potassium iodide is an ionic compound. So we need the charges, which are positive and negative ones. You can crisscross those numbers to get the ratio to make this ionic compound neutral. So it's 1 to 1, so the formula is just Ki. And we'll put AQ here because it's in solution. Now the other reactant is lead 2 nitrate. So the symbol for lead is Pb, has a 2 positive charge, and nitrate is NO3 with a 1 negative charge. So the formula for lead 2 nitrate is Pb and NO3 in parentheses, and there's 2 of them. That's also in solution. At this point, you should recognize this is a double replacement reaction. We have 2 ionic compounds, and the cations and anions are just going to swap partners. So let's predict the products. The potassium will end up being with nitrate, and because they both have 1 positive, 1 negative charges, it's going to be in a 1 to 1 ratio. All right. Alkali metals and nitrates are soluble, so this is going to be dissolved in AQ. You'll get a formula sheet with the solubility rules when we get there. And then the other product is lead 2 iodide. So you crisscross the charge, you get PbI2. And that's going to be a precipitate. Because although most halide salts are soluble, lead 2 is an exception. Let's balance this. We'll separate the reactants from the products. So there's 1 potassium on the reactant side, there's 1 iodide, there's 1 lead. If the polyatomic ions are not unchanged between the reactants and products, you should keep them together. And in our class, in this chapter at least, they're never going to change. So I'm going to put NO3 here on its own line. And there's 2 of them. Notice the 2 outside the parentheses. If you separate the N and the O, you're going to have a much harder time balancing this type of equation. Now over to the product side, I'm just going to write them in the same order so I can compare them side by side. I've got 1 potassium, 2 iodides, 1 lead, and 1 nitrate. So at this point you can balance either the iodide or the nitrates. It's not going to matter much. I'm going to go to the reactant side, multiply where I see iodide by 2 to balance that. So I'm going to put a coefficient of 2 in front of potassium iodide. Don't forget to update the potassium. I got to go over to my product side and balance the potassium. And that's also going to take care of the nitrate. So here's your balanced equation for the double replacement reaction between potassium iodide and lead 2 nitrate. Later on, you'll learn that we're not telling you the full truth, but you'll learn that when we get to net ionic equations.